Hi guys, Ameya here and welcome to Want to Learn Programming. This is the 11th video in the series Basics of C Programming. In the previous video, we saw what are operators and we also looked at arithmetical operators, relational operators and logical operators. So in this video, we will look at what are bitwise operators, assignment operators and special operators. We will also look at a sample program which uses some of the operators so that we can use the same kind of logic for writing C programs. So let's start with bitwise operators. Bitwise operators are ones which perform bit by bit operations on the operands. It converts the two or one operands into binary and then performs the operation. So, to understand this, we will have to look at the truth table for these binary operations. Assuming that we have two operands P and Q, we can write this truth table. This is P and Q, this is P or Q, and this is P XOR Q. This XOR operator is actually the dissimilarity operator. That is, if both of the operands are true or both of the operands are false, then the answer of this is false. But if one of the operands is true and the other is false, then P XOR Q is true. So looking at this table, we can understand that when P and Q are equal to 0, that is false. P and Q equal to 0, P or Q equal to 0, and P XOR Q is also 0 because P and Q are both same. Similarly, for P is equal to false and Q equal to 1, that is true. P and Q is 0, P or Q is 1, and P XOR Q is 1 because these both are dissimilar. And so on. We can look at the truth table to find out what happens when you perform certain operation. So let's look at one example for bitwise operators. We take the example as the first operand is 25 and the second operand is 15. 25 is written as 11001 and 15 is written as 01111 in binary. So let's look at the bitwise operators. This is the binary AND operator. It checks if both the bits are present in both the operands. That is, if bits are present in both the operands, that is if both are 1, then the answer will be 1. So 25 and 15 is 01001 because 1 and 0 is 0, 1 and 1 is 1, 0 and 1 is 0, 0 and 1 is 0, and 1 and 1 is 1. So this performs this bitwise operation. So 1001 is equal to 9 in the decimal system. This is binary OR operator which checks if both the bits are 1. So 25 or 15 is 11111 because 1 or 0 is 1, 1 or 1 is 1, and so on. This 5 ones translates to 31 in the decimal system. This we have already seen is a binary XOR operator. It checks if the bit is present in only one of the two operands, that is if both are dissimilar. So 25 XOR 15 is 10110, that is 22. You can look at these two and then come to a conclusion that this is the answer. This is the negation or binary complement operator. It flips zeros to 1 and 1 to 0. That is the complement of 25, that is 11001 is 00110, that is translating to 6. This is the shift right operator. It shifts the bits to right by the number of bits specified. So 25 right 1 translates to 01100. When this moves to right, this one goes and this replaces here, this comes here, this comes here, and this one comes to the second place. And a 0 is put as prefix. So this translates to 12 in decimal system. Similarly, the shift left operator does the same things by shifting the bits left. So similarly, if you shift these left, these two will go, these two will come here, and this one will be in the third position. And it will be postfixed by two zeros, which will translate the value to 4. So next we will look at assignment operators. Assignment operators are ones which are used to assign a value, operation or variable to another variable. We will look at all the operators. This equal to is a simple assignment operator which we commonly and frequently use in our day-to-day life. This is the add and assign operator. It adds the left operand to the right operand and assigns the result to the left operand. That is, if you write a plus equal to b, then the answer will be a is equal to a plus b. Similarly, this is the subtract and assign operator. It performs the same operation as add, but it is a subtract operator. This is star equal to, that is multiply and assign operator. It multiplies the left operand and right operand and assigns it to the left operand. That is a star equal to b will be a equal to a star b. This is the divide and assign operator. This performs the same task, that is a slash equal to b is equal to is translating to a is equal to a divided by b. Similarly, these are the other operands, that is modulus and assign, left shift and assign, right shift and assign, bitwise and assign, bitwise or and assign, and bitwise XOR and assign. These work the same way as was mentioned in the other operators. I will not be going into detail, but you can look at the example and find out by pausing the video. Now let's look into what we call special operators. As the name suggests, special operators have special functions. There are four common special operators that we use. The first operator is size of operator. It actually returns the size of a variable in bytes. So if I have int a, then the size of a will be 4 bytes. That is, we know that the size of integer is 4 bytes. Next is the address operator. It returns the address or the location in memory of the variable which you have pointed it to. So and a will give you the address of the variable a or the location where a is stored in memory. The star is the pointer operator. It points to a variable by storing its address. This is star p. We have seen these pointers briefly while studying the printf and scanf statements, but we will be addressing this pointer in detail in our future videos. This is a comma operator. This is used to link expression together. We have seen this while declaring two variables. We actually declare int a comma b. So here it is int a is equal to 10 comma b is equal to 20. So this is used to link expression together. Next, we will move to what we call as the ternary operator. The ternary operator is used as a conditional operator. It uses three operands for the operations. As the name suggests, it is the ternary operator with three operands. We will be studying more about this ternary operator in decision making, the third session. So let's look at a sample program for using these operators. This is to add two numbers and find the size of the variable. Let's try to make the program user friendly. So while writing the program, first we will be using the header files, that is stdio.h and stdlib.h. Next, we will be using int main and the two flower bases used to open and close the int main function. First, we will be declaring the two variables a and b and also the sum variable which is used to store the addition of a and b. Next, we will ask the user to enter two numbers. We will scan two numbers and take input as percentage d in the form of ampersand a and ampersand b. Please note that this percentage d corresponds to this ampersand a and the second percentage d corresponds to the second variable b. So we use sum equal to a plus b. We are using the assignment operator as well as the arithmetic operator over here. The sum of percentage d and percentage d is percentage d. The first percentage d corresponds to a, second to b, and the third to the sum. Next, we will print the size of variable, that is, the size of variable is percentage d, and the operator we used is the special operator size of sum. Next, as we finish this function, we use the return 0. So let's look at some practice questions which you will be able to solve. I'll be keeping this video for 10 seconds pause so that you can pause the video and check the questions. The answers of this question, that is the solutions, will be given in the link description below after some time so that you can find the time to solve these questions and then look at the answers and check whether your answers are correct or not. So if you like this video, click on like, share and subscribe. Thanks for watching. In the next video, we will look at decision making in C. Thank you.